guys, this is class Adda and I am Pritham. So today I came the new chapter of class 11. This is motion in straight line. So my aim is to help the class 11 student to overcome this pandemic situation of COVID-19. So let's see how much I can help you guys. So straight in a motion in a straight line. So what does we know about the motion? So motion, actually if an object is change its position with respect to time, then I will tell this is a motion. Now motion is various kind of, suppose an object is moving in a straight line, then I will say this is a rectilinear motion. Okay, so so what I can say rectilinear motion, if the object is here and is changing its position from this to this and it's in straight line, so this is a rectilinear motion. Okay, so we'll see all these details here in this chapter, and we from the morning to before we going to sleep at night, there is a lot of motion in front of us. Suppose in our body the blood circulation, in we are traveling through cars, in every case we are go through some various kind of motion. So that study of motion is so important for our practical life. Okay, let's see. So here's one term is there. This is known as kinematics. What is kinematics? Kinematics means the study of motion. When we study the motion without know the cause for that, that is actually the motion is created exactly basically due to some kind of force. It may be gravitational force, it may be electromagnetic force, or it may be our physical force. Okay, that means mechanical force. Now when we don't study that force but we study the motion, such kind of study is known as kinematics. That means study of motion without its reason. That means for which purpose this motion is creating, we will not go through this part, but we will study the motion, the how the pattern of motion, how we can calculate the motion, we can handle this motion. So all these terms are known as kinematics. Okay. So now let's do some term which is related to a motion. The first term is position. What this is position. What does position? Position means whenever an object is there and we are representing these objects with reference to with respect to some reference point, so this is known as position. Suppose I am posing here as a point. Okay, suppose its name is P. Now how I am describing this one with respect to some coordinate system. Suppose this is my 0 point O, and I go through this direction, this is x1, and in this direction I go how much, this is y1. So how I represent this point is x1 comma y1. So this is the position. Okay, so whenever I am representing an object with respect to some reference, then it is known as the position. Now exactly whenever we describe, in case of motion, when we describe the position, so is with respect to its one's reference frame. Reference frame represent means I am representing this one coordinate system along with time. Suppose this is t1. That means at when I am starting a study, this is a t1 time, and whatever the position of these objects, and at t equal to t2 times, what is the position of this things. So if we again we will I will discuss all these things in detail, so then it will be more clear. But still now you just consider these things. Then whenever I am representing some objects with respect to a reference frame or reference position and with respect to time, this is known as position. Okay, now next term is coming path length. What is path length? Path length means whenever an object, suppose at t equal to 1 time an object is here, that is here, this is x1 position, and t equal to t2 time, that is representing at x2 position. So this is p1 and this is p2. So how is go from p1 to p2? That is the path line. Up now this may be in this way, or this may be in this way, or this may be in this way. Okay, so all of them are, I can represent as a path line. Suppose this is path 1 and this is path 2, this is path 3, this is path 4. Okay, so whenever an object is changing its position with respect to time, then when we connect all of them, that means whatever the path is followed, and this path is known as the path line. Okay, now this path line is a scalar quantity. Scalar quantity means it does not have any particular direction. Okay, suppose an object is moving from this direction to this direction, from here to here, but here doing coming, this two is travel like that only. Okay, so this will be a path line, so its direction is changing continuously. Okay, now I'm moving towards another term which is known as that means whatever the distance traveled by an object, this is a path. Now another term is coming, that is distance. So what is distance? Distance means whenever one object is changing its position with respect to time, then I am connecting its final position and initial position with the particular straight line, then this will be a distance. Okay, so suppose this object is moving, this is the initial position, this is the final position. So now whatever the distance, I will join this one, so I'm giving this one as a red mark. So I'm joining this one, it's a straight line, then the distance from x1 to x2, this interval, this will be this distance, whereas the path will be the way which it has been followed, this will be a path. So what we have observed here, so distance is a vector quantity, that is it has a particular direction as well as magnitude. Okay, so how will define get this one? We will find the final position and we will find the initial position, then we subtract it to a straight line, then we will get the displacement. Okay, I think all these things are you have started in the previous class also. Okay, that's why I'm not going through details about all these things. Now you see, is it possible that distance and path should be equal? Yes, maybe sometimes it's possible, but it's not always same. Okay, suppose an object is coming from this direction to this direction. Okay, now if this is x1 and this is x2, this is one is t1 time and this is for t2 time. So now you see what is the path length. So you see, this is, suppose this is 5 meter, so path length equal to also 5 meter, and whatever the distance, so distance equal to also 5 meter. So when an object is moving in a straight line, then I can say path length is equivalent to distance. Okay, now when an object is not following in a straight line way, suppose an object is moving from this direction to this direction. Okay, so now if we join the initial position and final position, then it's coming like that. Okay, so now is suppose 5 meter. So here the distance is how much? So here distance equal to 5 meter, but path length. Now you see, for path length is coming this way, again this way, again this way, again this way, again this way. So it's not the 5. Suppose it is 10 meter. So path length is not equal to path length is not equal to distance. Okay, now there is another question comes, is it possible the path is will be 0 or distance should be 0? So let's see what happens on that case. The path length never be 0, but a distance can be 0. Whatever the definition of distance we have given, that the final position minus the initial position. Now suppose an object started from here and it comes round around here and it can come back here. Okay, so whatever the distance travel, so But first I am finding the path length. Suppose its radius equal to r. Okay, so whatever the perimeter will be what, 2 pi r. Okay, so this, whenever I started from here, again coming again, return to this one, how much length I have traveled. So I have length of this perimeter length, so this will be my path length. Okay, so this should be my path length. But whatever my distance, so you see, whatever the final position, initial position here, whatever the final position here, so if subtract the final position and initial position, then is equal to 0. That's why the distance here equal to 0. That means the distance can be 0, but the path length never be 0. If an object starting from one point and again come back to this point, then they should, on that case, the path length not be 0, but the distance will be 0. Okay, so such kind of question may ask in the question. Okay, now let's move on to the next topic. What is the next topic? Okay, next I'm coming to velocity. What is velocity? That means when an object is changing its position, with respect to time, that means per unit time how much distance is traveling, this is known as velocity. So velocity equal to distance by time. That means per unit time how much distance is traveling, that one is the velocity. Okay, now there is some term is coming, average velocity. Okay, suppose an object is moving here, suppose this is my reference frame and it started from here x1 and is ended to x2 and it started from time equal to t1, this is time equal to t2. Okay, on this case I have to find out what average velocity. So how I will find the average velocity? Average velocity. So average velocity, how I find this average velocity? So average velocity equal to its final. So I am writing in numerical terms so that I can. So equal to x2. x2 means is final position minus is initial position, that is x1, and how much time it has taken. So final time equal to t2 and initial time equal to t1. So this should be my average velocity. Okay, so what is the benefit of average velocity? Average velocity, because in some cases we see that suppose a car is moving, so is starting, then again velocity is reducing, some obstruction has come and again velocity is reducing, then again it is pick up to its full final position. So in this way a velocity is changing, and as a result of when somebody is asking what is the velocity of this car, so on the situation we have to take an average velocity calculation. So on this, how we take the average velocity calculation? We'll find the final position, we'll find the initial position, and then we divide it by total time, then it will get the average velocity. Okay, so this average velocity is represented by v bar. So sometimes it's written also in the form of v bar. Okay, so there's the thing. Now how we can represent an average velocity graphically? Suppose you see this one, x1 and x2. So whenever this is suppose a curve it is following, on this situation how we will do, we will get the slope of this one. This will be my average velocity. So how I can represent slope of a position curve. Slope of a position curve represent average velocity. Okay. Suppose this is P1 position, this is my P2 position. So slope P1 by P1 minus P2. Slope P1 and P2 will be represent the average velocity. Okay. Now, so I am not going through details of all these things. If you go through NCERT books, there is a lot of things that you have to understand. I will try in this video that in a short interval, so that I can give a little basic idea, so that you can go through books and you can get a more view regarding this. Okay, so just and for that I want to try to give a basic idea in this video. Now average velocity may be positive, may be negative. How we can curve like this? Suppose an object is like that. So this is position, this is time. So you see, that means with the time the position is changing, so velocity is positive. Suppose this is x1, this is x2. Here you see this difference is this is t1, this is t2. So here velocity will become x2 minus x1 by t2 minus t1. Okay, so here this x2 minus x1 is a positive term, here t2 minus t1 is also positive term, because this term is coming here, this term is coming, so as a result of I'm going positive term. Okay, and what about the negative velocity? It should be like that. Suppose this one, so this is x, this is p. Now you see, when I'm changing with respect to time, this is x1, this is x2. So x1, x2 is less than the x1. So in that case, I will change. I will say that my average position is average velocity is negative. Okay, and whenever the object is in rest, then average velocity will be 0. In rest means it's not changing with respect to time. The position is 5 meter. So on that case, after this is 2 seconds, is also 5 seconds. After 5 seconds also is also 5 meter. So on this condition is not changing its position, so the average velocity will be 0. Okay. Now so this is about what velocity. Velocity means distance by time. Now if an object, we know that whenever an object is moving, is follow a path. So we have to so whenever object is following a path, so on that case how we take the average term. So on this case another term is come, that is speed. So speed means what? That is the path it follow by time. Okay, suppose on this case an object is moving in a circular way, and this, suppose an object is moving in circular way. So it's coming from this direction to this direction. So whatever the path is followed is equal to 2 pi r, and whatever the time, suppose it started from here, t1 time to t2 equal to 5 seconds. So this will be my average speed. Sorry, this is the my speed. Okay, and in case of what is the velocity? So velocity will be here equal to 0 by 5, that is also equal to 0. So here I have observed that speed is a scalar quantity, that it does not have any direction. Though it has a magnitude, but it does not have any magnitude. It's a direction. Here velocity is a vector quantity because it has magnitude as well as direction both. Okay. Now so here another general term is asking that average, they are saying that in general speed is greater than in general speed is greater than velocity. That means there is a possibility, but it does not mean the velocity can be average and greater than the speed. Okay, is it clear? Now I'm coming to another term. This is known as instantaneous velocity. What is instantaneous velocity? Suppose an object is moving from one position to another position, so it goes to a various type of interval. Suppose this is the object. So suppose an object is here and is coming here. So suppose this is a path it followed. Okay, so what about the distance? So distance is equal to this one. Okay, this is x, this is my t. So this is p1, this is my p2. Okay, so if I find the average velocity, so average velocity I will find somewhere here. Okay, in this position. Now if we take another 2 point here, another 2 point here, so whatever the velocity is, on that case I will get also here. If we take another 2 point here, another 2 points here, so also get. That means whenever I am taking for a very short interval of time, suppose a car is moving from 0. Suppose I am starting from a car and it's going to a maximum speed, then again it's gradually decreasing. But if I told you in between an intermediate time, then what will be the velocity, so you can't say. You can do it average, you can do it average speed, average velocity, whatever, but at a particular interval of time, whatever the velocity, this is known as instantaneous velocity. It is represented by how? Delta v. So delta v, how is represented? Delta x by delta t. Okay, so what is delta x? Delta x means for this small, this is known as delta x. For a small interval of time, whatever this interval of time, this is the interval of time. So this is the delta t time. So very small interval of time, how the velocity I am getting, this is my instantaneous. So how it is represented? Limit del t tends to 0. That means I am considering, the expression should be like that. Instantaneous velocity delta v equal to limit del t tends to 0 del x by del t. So what does it mean? What this means, del t tends to 0. That means it's around 0 but not exactly 0. This is a very small amount but not 0. Okay, so on that situation, whatever the distance we are achieving with a particular time, that is my instantaneous velocity. So in all the cases, the unit should be meter per second. Okay, so since you have to know all these things, because you have go through class 9 and class 10, so I think I should not discuss all these units, dimension and all these things. Okay, now let's move on to the next thing. Now next, another term is coming, uniform speed or uniform velocity. So uniform velocity means if my velocity is not changing with respect to time, this is known as uniform velocity. Suppose one object is this one. So this is the graphical representation of uniform velocity. So it's in x1, this one, x2, this is x2, x2. So suppose this is t equal to 5 seconds and here t equal to 10 seconds, and here the change, suppose it is suppose this is 20, this is 10. Okay, so what will be the velocity? So velocity v1 equal to 20 minus 10 by 10 minus 5, so equal to 10 by 5, that is 2 meter per second. Okay, now here you check, on that case also this is become 30 and here is become 15. So on this case delta v2 or b2, I can say 30 minus 20 by time 15 minus 10, so it's come 10 by 5, that is equal to 2. So in this case you see that my velocity is changing, is not changing. Okay, velocity is fixed. So such kind of with respect to time, in case of 5 seconds, in case of not 10 seconds, in case of 15 seconds. So if it is follow in this pattern, so I will say this is a uniform velocity. That means it does not change its velocity with respect to time. Okay, now I'm moving to next next topic, that is, now I'm coming to another topic, that is acceleration. What is acceleration? You know the definition of acceleration. What is acceleration? So acceleration is change of velocity with respect to time. The previous one is change of position with respect to time. Now change of velocity with respect to time. So acceleration is denoted by a. So a equal to velocity v2, final velocity, minus initial velocity by final time minus initial time. Okay, so you see this is a change of velocity. Velocity is vector quantity, that's why this acceleration also vector quantity. Okay, Acha, what will be its unit? So it's a change of velocity, that means meter per second, and below rate of change as a result of meter per second square. Okay, so as we have discussed, in case of velocity, in case of acceleration also there is the average acceleration, average acceleration, and instantaneous acceleration is also there. Average acceleration means how we can check the average of acceleration. That means how velocity is changing, we are taking this separate acceleration and then we are doing the average acceleration. Okay, and what is instantaneous acceleration? Instantaneous acceleration means for a particular instant of time, how I am achieving my acceleration. This is known as instantaneous acceleration. Now they have given some graphical representation. Suppose positive acceleration. So positive acceleration is how they have given. They have given if position is x and the time is just t. So this is my positive acceleration. Okay. How this one? So you see, suppose from here to here or here to here, you count this one in this direction. Suppose this is a1, this is a2, this is a3. So on that case, my acceleration is changing. That means a2 greater than a3 greater than, this is a3. So a3 greater than a2 greater than a1. Okay. So on that case, I can take a that means final acceleration minus initial acceleration by time. Okay. In this way, I can find the average acceleration. Okay. Now, how I can find? So average acceleration is represented like that. A bar equal to final v0 minus suppose vf minus v initial by tf minus t initial. So in this way, I can calculate the average acceleration. Okay. So there are some graphical representation also. Just you go through once all of them, then I think it will be clear. The first one is given, the object is moving in a positive direction. Oh, so, sorry, I have then negative acceleration. Negative acceleration, how much? This kind of acceleration is known as negative acceleration. Okay, and what is this is a negative acceleration. This is x, this is time. And when a graphical representation is done, so I already discussed such kind of representation where this is x, this is t. So in this case, I already see there is no change of velocity. That is uniform velocity. So if it is uniform velocity, that is there is no change of acceleration. That's why this is a I can say this is uniform acceleration. That means acceleration is fixed. Okay, or zero acceleration I can say. Now, discussing some graphical representation. Suppose first one, a graphical representation. Suppose this is my initial velocity. Okay, that means v0, and is after a particular time is raised to this one, final velocity v. Okay, so this is my time. This is my time. t10 meters taken. So finally, this is my final velocity v. Okay, so I can say this is my, if we describe this one, this will be an object is moving in a positive direction with a positive acceleration. So you see that velocity is changing and it's a positive value I'm getting because v is greater than v0. So as a result of v minus v0, this term should be greater than equal to 0. This positive term, here time also positive term. As a result of, I will get a positive acceleration. Whereas if a graphical representation is like that, this is like v0, this is v. On that case, if you see final v minus v0 is less than equal to 0 because this v is less than v0. So on that case, I will get a negative acceleration. Okay. Now, if an object return to its original position, then how? Suppose a graphical representation is like that. Okay. Now, suppose this is my 0 point. Now, an object started here and is gradually decreasing its velocity. Gradually decreasing this velocity in the sense of this one. That means suppose I can say a car is picking up, then is gradually decreasing its velocity. Okay, so such kind of velocity is this one. Okay, now in some cases it changes its position. Suppose a car is moving and suddenly it's starting here and then it's changing its position. Whenever this position, suppose this is positive 5, when up is coming negative 5. Okay, so why this negative current? Because the current is previously it was going to the positive direction, now it is coming to the negative, it is reversing this position. Okay, so as a result of acceleration, whatever acceleration I am getting, this is in negative. Okay, because acceleration is a vector quantity, it consists of a magnitude as well as a direction. So in this way we can say describe various kind of acceleration. Okay, now